Identify the domain of the function. Okay, well, when it's asking you to identify the domain, guys, you shouldn't be talking, I'm teaching. You immediately know that they're talking about what? Hold on, here's it says identify the domain of the function. When you hear the word domain, you immediately think about x values. Okay, now the x-axis is this horizontal axis that runs left and right. So if I follow this graph to its left side, it has an x value of -4. If I follow this graph to the right side, it has an x value of +4. However, just knowing the numbers is not very helpful with this problem because every single choice has a -4 to +4. Okay, so that doesn't really help us. What will help us is looking at the signs. Anytime it's an open circle, it means that there's not actually a point at -4. Okay, it's not equal to -4. So for that reason, you should not have an equal to bar with the sign beside the -4. So A and B are out. You should have an equal to sign though beside the +4 because that's a closed circle. There is actually a point sitting there that has a y value of 4. So equal to 4. Now, you have to decide which of these two are correct. I am going to split those apart. Instead of writing it in one statement like that, I'm going to write it as two different statements. First, everybody can see that that says x is less than or equal to 4. What gets more confusing is when it's this way. See how the inequality sign is opening towards the x? So down here, I need to make sure it continues to open towards the x and not the -4. So see, when I rewrite this as two separate statements instead of one, this sign has to flip around and open towards the x like it was there. So when I rewrite D, it'll be x is greater than or equal to 4 and x is less than -4. Now, x represents the graph. It represents every point on this graph. So like this point would have an x value of 0, just an x value. This point would have an x value of 1. This point would have an x value of 2. This point would have an x value of 3, and this point would have an x value of 4. This point would have an x value of, and then this point would have an x value of -2. This one would have an x value of -3, and this one has a value of -4, but it actually it doesn't reach it. So, aren't all of those numbers that I just listed out less than or equal to +4? Pay attention. Isn't every single number that I just wrote out, every single x value, less than or equal to 4? And aren't all of those numbers greater than -4? So that's why C is correct. D says that all of the numbers are greater than or equal to 4. Well, none of these numbers are greater than 4. So that's out. And none of those numbers are less than -4. That would be this way. So the sign should be going to any time you're writing, the sign should always go that way. Unless, okay, let me show you what D would have looked like. If D had been the graph, none of this would have been there, and the graph would have been like a closed circle, and then it would have gone this way, and an open circle, and it would have gone this way, and none of that would have been there. That would be what D would look like. Okay? All right, now we're going to start the new packet. So I am about to hand it out. I am going to do like a short little lesson that will lead into what we're learning today. Okay, today we're going to start something called quadratic functions. In Unit 2 was all about linear functions. Okay, and we know with a linear function, they are always in the form y equals mx plus b. Okay, remember, you're not writing this, you're just paying attention. So, Unit 2 was all about linear functions, which are always in the form y equals mx plus b, where m is your slope, b is your y-intercept. The most basic linear function is y equals x. Okay, that's the most basic of all linear functions. In this function, what is the slope? 1, because there's an understood 1 right there in the end place, right? And what is the y-intercept? 0, because there's an understood plus 0 in the b place. Okay, but remember, that can be written as just y equals x. You don't have to write the understood 1, and you don't have to write the plus 0. To graph this, it would just be 0 would be your y-intercept, and then up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1, okay? And then when you connected them, it would look like this. Okay, that is the most basic of all linear functions. Now, that has a name. It's called the parent function. Okay, parent function. It's just basically like, you all know what a linear function is. This is the original linear function. It's called a parent function. Now, from this, we know that the lines can go up and down. Like if you change this number, won't it cause the line to go up if it's plus something? And if you change it to minus something, won't it cause the line to go down? And if you change the m to something other than 1, won't it change the steepness of the line? Okay, but before any of those changes are made, this y equals x is called the parent function of linear functions. Today, we're going to be learning about quadratic functions. And the parent function of a quadratic function looks like this. Y equals 1x squared. Okay, there's an understood 1 there, and then there's nothing at the end. Okay, so we're going to graph the parent function of a quadratic function using a table of values. Now, if you have a table, y equals x squared is your equation, what can you do with these x values they've given you? You can plug them in. So if you take a negative 2 and you replace the x with it, what is negative 2 squared? Positive 4. Now, why is it a positive 4? Correct. If you take a negative 1 and you plug it in, what is a negative 1 squared? A 1. If you plug a 0 in, you get, and if you plug a 1 in, you get, and if you plug a 2 in, you get. Now, why do you think it is that this negative 2 made a 4 and the positive 2 made a 4? Right, because even though this is negative, when you square a number, the two negatives cancel each other out. So basically, negative 2 squared and positive 2 squared are the exact same thing. Because when you square the negative negative becomes a positive. So that's why you get the same thing, and that's what causes the parabola to occur. Okay, so now let's graph this. Negative 2, 4. How do I plot the point negative 2, 4? Left 2, up 4. Okay, how do I plot the point negative 1, 1? Left 1, up 1. Okay, what about 0, 0? Just the origin. Okay, 1, 1, right 1, up 1. And then 2, 4 would be right 2, up 4. Okay, and so see how like when you had negative 1 squared, it was 1, and positive 1 squared was 1? Okay, those points are in the same place but on opposite sides. Same thing when you did negative 2 squared, you got positive 4. And when you put in positive 2 squared, you got positive 4. And it makes a U-shaped graph called a parabola. Now, some people want to try to say that it's a V. But think about it. With a V, isn't that just two straight lines connected at the bottom? And straight would have had to continue this way. Okay, so it does not make a V. These points are increasing faster each time, which causes it to curve, making it appear more of a U shape. Okay, so that is the parent function of quadratic functions, the original quadratic function. It starts at 0, 0, it has a point at 1, 1, and negative 1, 1, and it opens up. Yes? You put arrows right here. I mean, you can, but I normally just don't put my arrows till the end. But like somebody asked earlier, somebody asked me, why did you continue your line through that point? Well, there are more points, we just didn't have them in the table. Think about it. If I had a negative 3 up here and a positive 3 down there, what would negative 3 squared make? A 9. And what would positive 3 squared make? 9. So technically we could have a point at left 3 up 9 and right 3 up 9. So that's why you would continue drawing, you would draw arrows because the parabola continues to go up forever. I mean, think about it. Couldn't I continue to list x values like negative 4, positive 4, negative 5, positive 5? And it would cause the parabola to continue to go higher and higher? Okay. The lowest or highest point on a parabola is the vertex. Okay, so for this parabola, do we have a lowest point or a highest point? We have a lowest, and it's right here. So that is your vertex, and they want you to label it. What are the coordinates of that vertex? 0, 0. I just filled it in right here. Can you click that middle button, play? Thanks. Play. Sorry. Okay. Shh. All right now. I just turned off the heater. Okay. The axis of symmetry the axis of symmetry is the line that passes through the vertex and divides the parabola into two symmetric parts. Okay, so we're going to draw in the axis of symmetry. It is a line that cuts through the vertex and will cut this parabola into two symmetric parts. Okay, because think about it. If this is the line of symmetry, the axis of symmetry, wouldn't this half the parabola fold over and land directly on that part of the parabola? Okay, they also want us to label the axis of symmetry. This is a line that cuts through the x-axis at 0. So it's x equals 0 would be the equation of it. Okay, because it cuts through the x-axis at 0. Okay, every quadratic function has a U-shaped graph called a parabola. Okay, so with linear functions, when a linear function is graphed, it's just called a line. But when a quadratic function is graphed, it's called a parabola. Okay, now let's look over to the other side of this page. Now, remember, the one we just did was y equals x squared, meaning there's a 1 in the a place. Okay, because remember, with a quadratic function, it's y equals ax squared plus bx plus c. Well, that means a is 1, and then b and c right now are 0. Okay, we're not doing any that are that hard yet. So right now, you just need to focus on what the a is, and for this one, it's a 1. Okay, now let's look at the next page. We're going to talk about graphing a parabola when the absolute value of a is greater than 1. Okay, so this time, over here in the left one, what is the a value? Isn't the a value a 2, and isn't that greater than 1? Okay, so let's talk about what that will look like. First, we have to fill out the chart. So when you plug in a negative 2, square it, and then multiply by 2, what do you get? 8. Do I need to slow down on filling in the chart, or is everybody pretty comfortable with filling in the chart? Okay, let me show you how you can also do it in the calculator. Okay, look, I'm going to type it in. Y equals 2x, but instead of x, I'm going to fill in the negative 2. Shh. Pay attention. Shh. Okay, look, that's your 2, that's your x value, and then squared. See how I just replaced the x with a negative 2? Negative 2 squared is positive 4. Positive 4 times 2 is 8. Okay, the way I squared it is right here. This button lit up in red. No. Shh. Guys, Sean. 2 times x, but this time the x is what? negative 1. And then we're going to square it and we get 2. Then we're going to type in the next one. 2 times 0 squared is 0. Then we'll type in the next one. 2 times 1 squared is 2. And then 2 times 2 squared is 8. So your numbers should be 8, 2, 0, 2, and 8. Okay, so now I'm going to plot these 5 points that were just created by plugging the x values in the equation. So, negative 2, 8. Now, before I do, what is this that's already been graphed? Right, that's the parent function. That's just y equals x squared, y equals 1x squared. So the reason it's there is so you can compare that to what we're about to put on there. Okay, so negative 2, 8 would be left 2, up 8. And then negative 1, 2 would be left 1, up 2. 0, 0 is at the origin. 1, 2 would be right 1, up 2. And then 2, 8 would be right 2, up 8. Okay, then connect them. Oh, I'm in trouble. Well, to be a V, this point would have to be moved over here so that it would be a straight line. And that's a totally different function that makes a V. Sorry, I was better at making parabolas earlier today. Oh, that's a little better. Okay, so remember, the one that was already on the graph in black, that's just y equals x squared, which has a 1 in the a place. The one that we just put on there in blue was y equals 2x squared. So what happened when the number was bigger than 1? It got skinnier, okay? And that's called a vertical stretch. If your a value is greater than 1, it's called a vertical stretch. Because you're stretching the parabola up, making it skinnier. Think about it like a person, but a person who's made of jello, and would be moldable. If you take their head and pull up, won't they get skinnier? Okay, it's a vertical stretch. Yeah. Okay, now let's do this one. This time, what is the a value? 0.5. So now let's plug in these 5x values for x and see what y values are created. When you plug in a negative 4 and you square it, that'll become a 16, and then half of 16 is 8. Then when you and remember, you can also type these in the calculator, okay? If you plug in a negative 2 and you square it, you get 4, but half of 4 is 2. If you plug in a 0 and square it, you get 0, and then half of 0 is 0. If you plug in a 2 and square it, you get 4, and half of that is 2. And then if you plug in a 4 and square it, you get 16, half of that is 8. So now we're going to plot these 5 points. Negative 4, 8 would be left 4, up 8. Negative 2, 2 would be left 2, up 2. And then 0, 0 would be at the origin. Positive 2, 2 would be right 2, up 2. And then positive 4, 8 would be right 4, up 8. Okay, so the green one is the one we just did, y equals 0.5x squared, which is a number smaller than 1. And what happened when the number was smaller than 1? It got wider. Okay, remember the black one is your parent function. It's the y equals 1x squared. The 2 made it skinnier, the 0.5 made it wider. When it gets wider, it's called a vertical shrink. Well, tomorrow I'm going to bring in a Slinky and do a little demonstration that will help you remember it. Okay, but imagine that you've got like a blob of slime or something. If you take it and you pull it vertically, it gets skinnier. A vertical stretch. When you stretch it out, it gets skinnier. The parabola gets skinnier as it gets stretched out. Okay, let me show you this. Let me pause. Okay, so we just learned what happens to a parabola when the A value is greater than 1. Okay? It either causes it to get skinnier if it's greater than 1. If it's less than 1, it gets wider. Okay? This is called a vertical stretch. It stretches up and gets skinnier. This is called a vertical shrink because it gets wider. Now we're going to learn what happens if it's less than 1. Okay? So first we have to fill in the table. This time, what is your A value? Guys, this time in this equation, what is the A value? Negative 1/2 x squared. So let's fill in the table. Go ahead and fill in -2 through +2. I don't think I need to do that with you anymore. I'm pretty sure you know how. Fill these in. When you plugged in a -2 into this equation, Marcus, tell us what you got. You took that whole 3 minutes to try to find lead? Okay, Sion. Okay. Okay. And -2. Good job, Sion. Okay, now we're going to plot those 5 points. Shh. How do we plot the point -2, -2? Left 2, down 2. How do we plot the point -1, -1/2? Left 1 and then down 1/2. And then 0, 0 is just at the origin. 1, -1/2 will be right 1, down 1/2. So in the same place, but on this side of the y-axis. And then 2, -2 would be right 2, down 2. So, remember, the black one that was already graphed for you is the parent function, and its equation is y equals 1x squared, or just x squared because you don't have to write the 1. Okay, so this one that's already up there is y equals 1x squared. The one you just graphed was y equals -1/2 x squared. So the negative controls whether it opens up or down. So since it was negative, it opened down. The 1/2 is a number less than 1, so it made it just a little bit wider. I know it's hard for you to tell, but can't you tell that this one's a little bit wider than the black one? And that was caused by the 1/2. Okay, now let's fill in this table, -2x squared. Okay.